Hey guys, by this point you should have already looked at the standard and broken it down and completed the worksheet in Google Classroom. And then you also should have taken care of getting the vocabulary cards completed and hole punched and then put into your rings. Now I know some of you probably have misplaced your rings, but you can simply get a sandwich baggie to put those in, and that's fine. So our standard that we're getting ready to cover is going to have us multiplying 4-digit numbers by 1 digit, and it's also going to have us multiplying 2-digit numbers by 2 digits. So what we're going to do first, just to introduce the lesson, is we're going to look at how we can multiply by multiples of 10, 100, and 1,000. Now, we're starting with this because it's a little bit easier for us to use the zeros and to get a pattern going. So I'm going to start off with a multiplication problem, and I'm going to start off with 4 times 10. 4 times 10. Now, when I'm looking at this multiplication problem, you're probably thinking, well, Miss Wilson, 4 times 10, that's 40. I already know that. But think about what this represents. So I know, because I have 4 times 10, I have 4 groups, and I have how many in each group? I have 10 in each group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I know that this represents 4 groups with 10 in each group. So I could skip count. I could do 10, 20, 30, 40. Or I know that I have 4 times 10. This is my base 10. So 4 times 10 equals 40. Now, let's say I was wanting to see a pattern with the zeros. Okay, I'm looking for a pattern with the zeros. Before I begin to tell you what this pattern means, let's have you look at another example and see if you can start to find the pattern. So I did my 4 times 10. We know 4 times 10 equals 40. So let me do 4 times 100. Okay? Now, I'm not going to draw 4 boxes and put 100 dots in each one. That's kind of crazy. Excuse me. But if I'm looking at 4 times 100, what could I do with this problem? Do you have any ideas? What if I went ahead and I looked at the base problem? What if I just looked at what I already know? What if I looked at 4 times 1? Could I do that? Absolutely I could. So if I looked at 4 times 1, that gives me 4. Now I know 4 times 100 is not 4, but I need to add my zeros back in. There are 0 tens and there are 0 ones, taking what I know about place value. So I have 4 times 10 equals 40. 4 times 100 equals 400. Starting to see a little bit of a pattern going on here with my zeros. Let me try one more. Let's do 4 times 1,000. Okay? Now, pretend these zeros aren't here. Let's get a base problem. 4 times 1. Is that something that I know? Absolutely. 4 times 1 is 4. And I know I have how many thousands? I have 1,000, 2,000, 3,000 to add. 1, 2, and 3, which gives me my 4,000. 4 times 1,000 equals 4,000. What's the pattern that I'm noticing? If you said that you're noticing the pattern of the zeros that are in the multiplication problem being the same amount of zeros in the product, you're identifying the pattern. When you're multiplying by 10, 100, or 1,000, just as a base number, you're going to have the same amount of zeros at the end of the base problem. So let me give you another example of a base problem. Let's say I had 3 times 60. Now, if I'm looking at 3 times 60, I'm sitting here thinking, all right, I could do 60. 60 plus 60 is 120. 120 plus 120 plus 60 is 180. I could do it that way. However, at this point, we shouldn't be trying to skip count looking at numbers that are this large. So I'm going to go ahead and take a step back, and I'm going to do what I was just talking about. I know that this 60 right here represents how many tens? It represents 6 tens. So I'm going to use the associative property of multiplication, and I'm going to break this down. I'm going to have my 3 times, I know there's 6 tens times 10 equals. So I took my 60 and I broke it apart. Okay, this number 60 represents 6 tens. This is saying that there are 6 tens. So I'm going to use the associative property of multiplication. If you'll remember, this means that we can regroup our numbers and the product is going to be the same. So right now I took my 60 and I broke it down. Now 6 times 10, could I do 6 times 10? Yes, but that's the same number that I have up here. So what I want to do is I want to make a multiplication problem that's going to give me a base problem. It's going to give me a multiplication problem that I'm more familiar with. So I'm going to take my 3 times 6 times 10. And I put my 3 times 6 together. Now, with our multiplication facts, we know that 3 times 6 is 18. So then I have 18 times 10. Now here's the cool thing with the 10. Remember up here when we did the 4 times 10 and we saw that we had the same number of zeros after the product? Well, how many zeros do we have after this? We have 1. So what I'm going to do is I'm going to look at my 18 times 1, and that gives me 18. And then I am going to carry my 0 over. So that way I have the same number of zeros in my number sentence as I do in my product. I wonder if that's true for a higher number. Excuse me, guys. So let me take 3 times 60 and let's do 3 times 600. Okay. First, I need to use the, what was that called again? The associative property of multiplication, which says I can break up and regroup this number. Okay, so I'm going to take my 3, keep it right here, and I know that this number represents what? How many hundreds? It represents 6 100s. So I'm going to do my parenthesis of 6 times 100. Okay. Now I want to regroup here so that way I have a base problem that I'm already knowing how to work with. So I'm going to regroup my problem to 3 times 6 times 100. Now, I'm set up the same way over here. 3 times 6 gives me what? 18 times 100. Let's do the same thing. If I were to take both of my zeros away, 18 times 1 gives me 18. And then I put my zeros back at the end. Because when we multiply by 10, 100, and 1,000, however many zeros are in the number sentence, that's how many zeros are going to be at the end of the product. So that gives us that right there. Okay? So we're using the associative property of multiplication to actually regroup the multiplication set within the number sentence. We're breaking it down into something smaller, and then we're beginning to look at what we can do. Now, I'm going through these steps of the associative property because it's important for you to understand how the associative property works. how you are able to regroup your numbers and you do end up with the same product. But let me show you a quick trick if you need a little shortcut. If this is something that you get and you understand, and we're not going to write down all of the steps for every single problem, let me show you something pretty simple. So I'm going to start with another problem. Move it up. I'm going to start with 9 times 5,000. Okay. Now I've already said what about the number of zeros. I'm going to have that many zeros in my product. Remember, your product is going to be your answer. So I'm going to look at my base problem first. I'm not even going to go that extra step with the associative property and break this up. I'm going to go ahead and look at my multiplication problem. 9 times 5. 9 times 5 is what? 45. And I have how many zeros at the end? I have 3. So how many zeros should I have at the end of this? I should have 3. Okay? Now, this is just a quick introductory lesson. This is getting you thinking about base 10, what we know about base 10. Most importantly, it's helping you understand that if you're multiplying by 10, 100, or 1,000, however many zeros you're multiplying by, that's how many zeros should be in your product. Also, if you start looking for your base multiplication problem, 3 times 6 is something that you already know. You're going to be able to figure out how to solve these answers pretty quickly. Make sure you check out the Wall-E video and then begin your practice buddy, which is going to allow you to practice breaking down these numbers. You guys have a great day, and I will see you on Thursday.